everyone, welcome to a new episode of the Windows Store Developer Applications blog. Today I will talk about the termination of application, and I will show you some tips and tricks to provide the best experience for the user of your application. Follow me. During the suspend and resume post-introduction animation, I mentioned that Windows could automatically terminate an app in some cases, such as high memory pressure. Let's use Task Manager to have the list of apps that are running on my box. I have already started a few Windows Store applications, such as the Store app, the Map, and the News. Sorry for the French name. And as you can see, three of them are suspended because I'm using the desktop on the foreground. So if you use the Windows tab shortcut, you can see on the left of the screen these three apps, the three Windows Store apps that have been started, the News, the Map, and the Store. And for each, I have a nice live thumbnail of what is going on in these three applications. And if I'm going to one of them, I switch to the application immediately. Let's go back to the desktop. As you can see, I switch to the Map, so it's no more suspended. And when I'm waiting a little bit more, it will be suspended in a couple of minutes. If you remember my previous episode about suspend and resume, it will be about 10 seconds to wait. Okay, now I have these three apps waiting here, frozen with no more thread running. So I want to simulate this situation where Windows will need a lot of memory for another application. So I have written such of application which is called bye-bye. And this application is quite simple. It's just a desktop application that allocates as many gigabytes as possible. And as you will see, if I zoom a little bit on the application, the memory consumption of about 10 gigabytes will force Windows to terminate my three Store application: the Store, the News, and the Map. Whoop, all gone. So all the application has been terminated by Windows. Let's stop this application so I can use my box. And if we go back to the list of applications on the left, as you can see, we still have the free application, but the live preview that we used to see here has just disappeared. It's no more available because there is no way for Windows to get the live preview of the application because the application are no more running. So it replaces this live preview with the logo and the color of the background. And if I want to go back to the map, for example, as you can see, it starts the map as if I have clicked on the tile. So let's see what the impact on our code with the same full of activation project I have used before. As we have just seen, a terminated app will be started on the user behalf. It means that the onLaunch override gets called with somewhere what was its previous running state. The information is stored in the args.previous execution state property. Let's see this in the code. So this is the code of my application, and the onLaunch override gets an launch activated event arg argument, and in this argument we get the previous execution state. And if we take a look at this enumeration, just go to source code and or with elf12, make it a little bit bigger. You can see that we have 5 different values. We have the not running, the suspended, the terminated, and the closed by user. And let's see each of them and in which situation your code will have to deal with it. So let's go back to the source code. The terminated state is obviously what we've just seen. Windows terminated the app, but the user should not even notice it, except for the splash screen that is shown by a user on your behalf when the app starts. So when you get back to run in this state, it means that the application needs to restore the navigation stack of the frame, and this is done by the suspension manager with the restore async call. And the second responsibility of the app in this case is to restore the content of the last page that was shown by the application before it was terminated. If you take the example of the mail app, for example, you start to write an email and then you switch from this application to another application, and then you keep on working, and Windows terminated your application, the email application, and you don't want to lose your email content. So in that case, you, as the developer of the mail application, had to listen to the suspending event, as I explained in the previous post, the previous episode of this series. And in the event handler, you save the content of your page before being suspended by Windows. So when you go back here in the terminated, you need to add your own state restoration in this part of the code here. Since it's an empty application, I had nothing to do. But this is where you should restore your application state saved in the suspending event handler. That was the first value of this enumeration. If we go back to the other values, we have another one which is easy to understand. It's the close by user. In the close by user, it's a very simple case. If I'm running the application, so I'm doing a Control F5 here, I will run the application and I will close it either with the Alt F4 shortcut or with the gesture, you know, when you bring your mouse on the top of the screen, you see it changes into a tiny hand, you drag it and you drop it to the bottom of the screen, and then it means to Windows, please close the application for me. So in that case, if you set a breakpoint just here, before checking the value, and I'm starting a debugging, I should stop here, and the value of the previous execution state is the close by user. This is what we expect. And in that case, in fact, we have nothing to do because the user explicitly, I will close the application now, the user explicitly ask Windows to close the application, meaning that I don't care. I don't need to use this application anymore. So we don't have to save anything, or we don't have to restore anything. What's the other value? We have seen terminated, closed by user. The suspended and running ones are how could I say that? Are two different facets of the same coins. I mean that if your application implements a custom protocol, it will be activated through the unlaunched override. Meaning that if you start it, if the end user activated through a link from another application, for example, and the application gets started, then the unlaunch will be called. But if the application is already running, then the state here will be running. If the application was suspended, then the previous state will be suspended. That's quite simple. The last one is the not running. This one might be a little bit hard to understand for you, but it's quite easy. If the application crashed, then you end up with this not running state. To simulate that, I've added a bad line of code. As you can see, I'm throwing an invalid operation exception when I'm clicking on one of the items. So we can see what's going on in that case. So I'm running the application, not debugging, running, Control F5, and I will click on one of the items. So this triggers the exception, and Windows will catch the unhandled exception and terminate the application for us. In that case, if I go back to the same line of code here, put a breakpoint, do a debugging session with F5. If I take a look at the previous execution state, as you can see, it's not running. Whoops, not running. So we've seen all the 5 different reasons how an application could has been ended before, and we've seen that only the terminated case needs special behavior of your application. Restoring the stack of the pages in the frame, which is done by the suspension manager. And if you have some special content to restore in the last page, then you have to do it and to do this code in this place exactly. Before ending this episode, I would like to mention 2 things. First, sometimes when your app is running outside of a debugger, still you will be interested in getting some traces. Because debug.writeLine is using the Win32 output debug string in debug builds, you can use debug view from sysinternal. I've downloaded the tool and you can using it. As you see, this tool catch all the traces that you can emit from your application or any application on the system through output debug string and kernel traces. So let's have a clean start. And if I'm running my application, you remember I've set all the debug.writeLine almost everywhere in my application. So I hope to get some traces when I run the app. So let's run the app, Control F5. I will run the app. I will end the app like this explicit termination. And when I go back here, close here, you see that I get all the traces, but wait, we don't get all the suspending. As you can see here, the unsuspending trace went a long time after I closed the application. Why? Because Windows waits for 10 seconds before raising the suspending event, even when the user explicitly asked to end the application. This is why sometimes in your debugging session with Visual Studio, you have to wait a few seconds before Visual Studio stop debugging. That's the reason. I hope you enjoyed this episode, and I wish you good luck with your Windows Store application development. Bye.